For 200,000 years, the human species looked up. To our ancestors, the night sky was a flat dome, a canvas painted with myths. The planets, Mercury, Venus, Mars, Jupiter, Saturn, were wandering lights. They were gods. They were omens. They were intangible, unreachable, and divine. They were out there, in a realm distinct from the dirt and water of Earth. Welcome to Axiox. Today, we are going to tell a story that only happened once and can never happen again. It is the story of the first golden age of solar system exploration. We often take for granted that we know what the surface of Mars looks like. We have high-definition video of the rings of Saturn. We know that Venus is hot enough to melt lead. But we forget that for 99.9% of human history, we knew none of this. The story we are covering today is based on the historical archives of NASA. It covers a brief, explosive window of time, roughly from 1962 to 2012. In this blink of a cosmic eye, humanity did something impossible. We broke the gravitational chains of our home world. We turned those wandering lights in the sky into physical places. We mapped them, we touched them, we crashed into them. And in doing so, we fundamentally changed our understanding of existence. This wasn't an easy journey. It was born out of war, driven by ego, and plagued by failure. But it resulted in the greatest expansion of human knowledge since the invention of writing. This is how we conquered the solar system in 50 years. To understand the first decade of exploration, we have to strip away the romance. We look back now and see science, but in the beginning, it wasn't about science at all. It was about survival. It was about dominance. The first era of solar system exploration was forged in the heat of the Cold War. In the late 1950s and early 60s, the United States and the Soviet Union weren't racing to find water on Mars. They were racing to prove whose rockets were powerful enough to deliver a nuclear warhead to the other side of the world. Space was just the high ground. This period was messy, it was desperate, and frankly, we were terrible at it. If you look at the logs from the early 1960s, they read like an obituary of robots. The early American Ranger probes, designed simply to crash into the moon and take pictures on the way down, failed over and over again. They missed the moon entirely. Their cameras didn't turn on. Their rockets exploded on the pad. The Soviets, meanwhile, were aggressively targeting Venus and Mars. They were launching planetary probes as early as 1960. But physics is a harsh teacher. Most of these early attempts failed to leave Earth orbit, burning up in the atmosphere. But then, the breakthrough happened. In 1962, NASA's Mariner 2 flew past Venus. It was the first time a human object had successfully encountered another planet, and the data it sent back was a shock. Science fiction writers had long imagined Venus as a tropical jungle, perhaps a bit warmer than Earth, maybe hiding dinosaurs beneath those thick clouds. Mariner 2 killed that dream in minutes. It revealed Venus was a pressure cooker, a hellscape with surface temperatures roughly 900 degrees Fahrenheit. It was the first hard lesson of the Golden Age. The solar system is not like Earth. It is hostile. It is extreme. While the Americans aimed for flybys, the Soviets, true to their bold engineering philosophy, wanted to land. They threw themselves at Venus with the Venera program. After many failures, they succeeded in 1970 with Venera 7. It was the first spacecraft to land on another planet and transmit data back. It only lasted 23 minutes before the heat and pressure destroyed it, but in those 23 minutes, humanity touched the surface of another world.
This early era was defined by this firstness. Who could get there first? Who could crash first? Who could orbit first? It was a competition that accelerated technology faster than any peacetime initiative ever could. While Venus was turning out to be a nightmare, all hopes turned to Mars. Throughout the 19th and early 20th centuries, Mars was the twin of Earth in the public imagination. Percival Lowell, an astronomer, had famously mapped what he thought were canals on the surface. People genuinely believed that a dying civilization might exist there, channeling water from the poles to the equator. In July 1965, NASA's Mariner 4 reached the red planet. This was the moment of truth. Everyone held their breath, waiting for the images. The photos that came back were grainy, black and white, and heartbreaking. There were no cities, there were no canals, there was no vegetation. Mariner 4 revealed a cratered, dead world that looked more like our moon than Earth. It had a thin atmosphere, no magnetic field to protect it, and it was frozen solid. This was a massive psychological blow to the public. The romance of space took a hit. If we were alone in the solar system, if our neighbors were just dead rocks and gas, why were we spending billions of dollars to go there? But scientifically, this was a gold mine. This is where the concept of comparative planetology was born. We stopped looking for aliens and started looking for answers about Earth. By studying the dead atmosphere of Mars and the runaway greenhouse effect of Venus, scientists began to understand how delicate Earth's climate really is. We began to see the solar system not as a collection of potential colonies, but as a laboratory. The climax of this Mars exploration phase came in the mid-1970s with the Viking missions. Viking 1 and 2 didn't just fly by, they landed. They sat on the surface, scooped up the red dirt, and ran biological experiments looking for life. The results were ambiguous, confusing, tantalizing. They didn't find clear evidence of life, but they found a strange, reactive chemistry in the soil. Viking stood as the pinnacle of Mars exploration for decades. In fact, after
Viking, we didn't go back to the Martian surface for 20 years. The disappointment of a dead Mars cooled the political jets. As interest in the inner rocky planets began to wane, something miraculous was happening in the orbital mechanics of the outer solar system. In the late 1970s, the giant planets, Jupiter, Saturn, Uranus, and Neptune, were moving into a rare alignment. This formation, a curved arc across the solar system, occurs only once every 176 years. It presented a unique opportunity. If you launched a spacecraft just right, you could use the gravity of Jupiter to fling you to Saturn, use Saturn to fling you to Uranus, and so on. A gravity assist. It would allow a single spacecraft to visit all the outer giants in a fraction of the time it would usually take. NASA called this the Grand Tour. This era gave us the Voyager missions, Voyager 1 and Voyager 2. If the 60s were about competition, the late 70s and 80s were about grandeur. The Voyager probes weren't just machines, they were cultural icons. They carried the famous Golden Record, a phonograph containing sounds of Earth, greetings in 55 languages, and music ranging from Mozart to Chuck Berry, intended for any extraterrestrial intelligence that might find them billions of years from now. But the science they returned was even more profound than the message they carried. When Voyager arrived at Jupiter in 1979, it revealed a chaotic, turbulent world. It discovered that Jupiter had a ring system, faint but present. But the biggest shock came from the moons. Before Voyager, we thought moons were just cold, dead rocks. Voyager looked at Io, one of Jupiter's moons, and saw active volcanoes spewing sulfur hundreds of miles into space. It was the first time active volcanism was seen off Earth. It looked at Europa, another moon, and saw a surface of cracked ice that looked suspiciously like the ice sheets over Earth's polar oceans. Suddenly, the dead solar system was alive with geological activity. The tour continued. Voyager 1 sacrificed a visit to Pluto to take a close look at Saturn's moon, Titan. It found a thick, orange atmosphere, the only moon in the solar system with an atmosphere dense enough to fly a plane in. Voyager 2 continued alone to the ice giants, Uranus and Neptune. In 1986 and 1989, it completed the reconnaissance of the solar system. We had done it. In less than 30 years, we had gone from launching metal balls that went beep to visiting every planet orbiting the Sun. This era concluded with one of the most famous images in human history. In 1990, as Voyager 1 was leaving the solar neighborhood, Carl Sagan convinced NASA to turn the camera around one last time. It took a picture of Earth from 3.7 billion miles away. The pale blue dot. That image changed the philosophy of exploration. It showed us that all our wars, our history, our ego, and our seemingly infinite world was just a pixel suspended in a sunbeam. It was the ultimate perspective check. By the 1990s and 2000s, the reconnaissance phase was over. We had flagged every planet. We knew they were there. The question shifted from, what does it look like, to, how does it work? We stopped sending flyby probes that zipped past a planet in a few hours, and we started building orbiters and rovers. We were going back, and this time, we were packing our bags to stay. This third era of the Golden Age was about depth. In 1995, the Galileo spacecraft arrived at Jupiter. Unlike Voyager, which flew past, Galileo slammed on the brakes and entered orbit. It spent 8 years circling the giant king of planets. It dropped a probe directly into Jupiter's atmosphere, which survived for about an hour, measuring the winds and composition before being crushed. Then came Cassini, launched in 1997, arriving at Saturn in 2004. This was an international beast of a machine, a collaboration between NASA, the European Space Agency, and the Italians. Cassini orbited Saturn for 13 years. It revolutionized our understanding of the rings, but its crowning achievement was the Huygens probe. In 2005, Cassini released the small European probe, Huygens. It fell through the thick orange haze of Titan. For 2.5 hours, it descended, and then it landed. It landed on a surface of frozen water ice, dampened by liquid methane rain. It remains the furthest landing ever accomplished by humanity. And of course, we return to Mars. After the long hiatus post-Viking, NASA adopted a faster, better, cheaper philosophy. Not all of them worked, but the ones that did changed everything. The Pathfinder mission in 1997 dropped a tiny rover named Sojourner, the size of a microwave oven. It proved we could drive on another world. Then came Spirit and Opportunity in 2004. These geologists on wheels were supposed to last 90 days. Opportunity lasted nearly 15 years. They found the undeniable chemical proof that Mars was once wet. They found ancient riverbeds, minerals that only form in water, and sedimentary layers. This era proved that the solar system wasn't just a snapshot. It was a dynamic, evolving history book. Mars was like Earth, but it died. Venus was like Earth, but it burned. The story of the solar system became the story of planetary evolution. So, looking back at these first 50 years, what did we actually achieve? The NASA history report on which this video is based draws a fascinating conclusion. The primary product of these 50 years wasn't Teflon or Velcro or even the rocks we brought back from the moon. The primary product was information. We started 1962 knowing almost nothing about our cosmic neighborhood. We ended 2012 with a detailed family album of the sun's children. We discovered that the solar system is more diverse than we imagined. We found oceans under the ice of Europa. We found methane rain on Titan. We found 1,000-mile-per-hour winds on Neptune. But perhaps most importantly, we learned about ourselves. Exploration is often framed as looking outward, but the first golden age of solar system exploration was really about looking inward. By studying the extreme greenhouse of Venus, we learned about our own atmosphere. By studying the impact craters on the moon, we learned about the violent history that shaped early Earth. By studying the solar winds, we learned how our magnetic field keeps us alive. We are the first species on this planet to know where we are. We know our address. We know our neighbors. The first 50 years were the prologue. It was the era of the firsts. The first flight, the first orbit, the first landing. That era is over. We can never discover the solar system for the first time again. Now, we are entering a new age. The age of settlement. The age of commercialization. The age where we don't just visit, but perhaps, eventually, live. But no matter how far we go in the future, whether we build cities on Mars or mine the asteroids, we will always look back at that half-century, from the crude beep of Sputnik to the sophisticated roving of Curiosity, as the moment humanity finally grew up. This is Axiox. Thank you for watching this history of our reach for the stars. If you want to join us as we cover the future of this journey, make sure you are subscribed. I'll see you in the next one.